Welcome all. In this video, we are going to talk about UV visible spectrophotometer instrumentation. We have already seen the theory in the last two videos. We are going to talk about the UV visible spectrophotometer instrumentation. Okay, normally for all the spectroscopy, there will be a basic components that is what you call it as a block diagram. So there will be a basic component of the spectrometer. So for one will be the source. So first will be the source. Okay, source of the radiation. So in UV visible spectroscopy, the source of the radiation for UV visible is deuterium lamp or hydrogen lamp. You can have a deuterium lamp or an hydrogen lamp. Deuterium is nothing but isotopes of hydrogen. So normally deuterium lamp, which is a little bit costly, is the source of the UV region, and the source of a visible region is normally a tungsten lamp. Okay, tungsten lamp. Okay, so this is the source of the spectroscopy, and from the source, for example, if it's an hydrogen or a deuterium lamp will produce radiation from 200 to 400 nanometers. From 200 to 400 nanometer. So, but our absorption of interest would be of only one wavelength, 1 nanometer, or one particular frequency, or one particular energy. For that, what you have to do, you have to pass the light to an what you call as a monochromator, a grating. I think in your physics you might have studied. Okay, it is also the filter. We can say it is a filter which is a monochromator. So monochromator, nothing but a what do you call it as a grating. Okay, a slit which allows only a particular wavelength. I think you might have studied in your physics about the grating and the monochromator. It allows only the energy of a particular wavelength to come out of the grating. Okay, so and it is passed into an sample. Okay, sample cell, normally silica or glass crucible is made as a sample cell, in which the samples are poured and kept inside the sample cell. So this is where sample, you can say sample cell. Sometimes what happens is from the monochromator, a part of the energy is cut off and a reference is placed over here. Okay, to make the absorption or to have a correct reading. To have a correct reading, there will be a reference. For example, the same wavelength is same light is split into two, and one part is passed into a reference, normally a blank, which gives a correction. Sometimes no blank may show some absorption. Okay, so to rectify that absorption, a blank is kept, and after that the sample, after the light goes into the sample, the light that is coming out is allowed into a detector unit. So detector unit detects the absorption, that is the log I naught by I. It detects the absorption. So one you know that initially the light will be having an intensity of I naught. After it goes into the solution, after absorption, the light will be having an intensity of I. So log I naught by I will give you the absorption. So absorption can be detected, and the light is from the detector unit, the signals are recorded. So last is the recorder. So last part is the recorder. So this is the basic block diagram for the UV visible spectroscopy block diagram. Okay, so it consists of an source. From the source, this is going to be the same for all the four instrumentation which we are going to study in our syllabus, for UV spectroscopy, for IR spectroscopy, for atomic absorption spectroscopy, or for flame spectroscopy. There will be a source. From the source, the light or the electromagnetic radiation goes into the monochromator. Monochromator allows only one wavelength to pass through it. So that wavelength is normally that the radiation is divided into two parts. One is passed to the reference, another one is passed to the sample. So sample absorbs the radiation, and the radiation after absorption is detected and is recorded. Okay, from this we can find the absorption of the UV radiation. Okay, this is for the instrumentation of the UV visible spectroscopy. We will meet in the next video with the theory of IR radiation. Until then, bye.